Compared to the previous method, naive Gauss elimination, or what we just call it to be Gauss elimination method, is more efficient when we solve large numbers of equations, for example n greater than 3. This method is an extension of the previous method of elimination. However, it has more systematic scheme and algorithm, using the forward elimination as well as the backward substitution procedure. In this example, we have three equations. Let's say your A matrix and B matrix are given, and then you are going to solve the unknown x. By using the Gauss elimination method, the first step is forward elimination, which changes the original format into this format, where you can see the first two elements here can be eliminated to be 0, and the element A and B in the second and third equation are changed during the forward elimination here. First of all, we obtain the pivot equation from the first equation here at the first row. Then we obtain the pivot element to be the A11 here, and this element can help to eliminate the A21, A31 into 0 later. To make A21 to be 0, we need the factor F21. So F21 can be obtained by A21 divided by the pivot element, which is A11. Then we can substitute the factor F21 inside this equation, where you have the equation 2, which is here, minus with the pivot equation 1, which is here, and then multiply with the F21. So if you take the second row minus with the first row, you obtain A21 minus A11, which is these two terms. And then you multiply with the F21, and you continue, take the A22 minus with the A12, so you obtain this term, and don't forget multiply with the F21. And for this you have A23, A13, so which is this, multiply with F21. Lastly, you have B2 minus B1 and multiply with F21. So we can see that A11 here can be cancelled, so A21 minus A21, you obtain 0. With that, we success to obtain the 0 for A21 component. And you see the changes for A22, it changed to A22 prime, indicate the first forward elimination. So this A22 prime is equal to this component here. So this component here is equal to this, and lastly the B prime 2 is equal to this component. The prime here indicates the change due to the forward elimination. To eliminate A31 to be 0, we need a factor F31, which can be found by using A31 divided by the pivot element A11 here. So you can obtain this factor F31, and then you substitute inside this equation. Take the equation 3, which is this equation, and minus with the pivot equation 1, which is this, and then multiply with F31. So take the A31 minus with A11 and multiply with F31, you obtain this component, and then you continue A32 minus with A12, multiply with F31, you obtain the second component here. A33 minus with A13, multiply with F31, so you obtain this component. Lastly, B3 minus with B1, and then multiply with F31. Then you obtain this. And you can see that this can be cancelled. A31 minus A31, this whole term is equal to 0. With that, we success to change A31 into 0. And here, you have the A32 changed to A32 prime. So A32 prime is equal to this component here. A33 prime and B3 prime is equal to these two components respectively. Previously, we obtained this equation, and to change the A prime 32 to be 0, we need further forward elimination. To do this, we set the pivot equation at the second equation here, With that, we obtain this to be the pivot element, and then we can find the factor F32 to be A32 prime divided by the pivot element A22 prime. Substitute the factor inside this formula where you have the equation 3, which is this component, minus with the pivot equation 2, so you have to minus the second equation here, and then multiply with F32. Multiply this with F32. So we start with the first element, 0 minus with 0, multiply with F32, you still obtain 0. Then second element, A32 prime minus with A22 prime, multiply with F32, you obtain this. A33 prime minus with A23 prime, multiply with F32, you obtain this. Lastly, B3 prime minus with B2 prime, multiply with F32, you obtain this. So you can see that this component can be cancelled, and A32 prime minus with A32 prime give you 0. So you obtain 0 for this component. With that, we success to change A32 prime into 0. A33 double prime is equal to this component, and B3 double prime is equal to this component. The double primes here indicate the changes due to the second forward elimination. After the forward elimination, you should be able to obtain these equations where you have 0 here, and you change the matrix into upper triangular matrix. Then we can find the solution by using back substitution or backward substitution. For the forward substitution, you start to solve the solution start from x1, x2, and x3. For backward substitution, you start to solve the problem from x3 followed by x2 and x1. By referring to the third equation, since 0 multiply this, you obtain 0, plus 0 multiply x2, you obtain 0, plus this term is equal to B3 double prime, and you can easily get the x3 by divide A3 double prime to be this answer. With that, you success to obtain the solution for x3. Then you continue for the second back substitution at the second row here. So take this component, multiply with this component, then you should be able to obtain 0, multiply x1, you obtain 0, plus A22 prime multiply with x2, you obtain this, plus A23 prime multiply with x3, you obtain this, which is equal to B2 prime. So you should be able to obtain this equation. And then rearrange the x2 solution to be in terms of x3, and then you substitute the previous x3 solution inside it, and you should be able to obtain x2 answer. Lastly, we perform the back substitution on the first equation here. So we take this row multiply with this column. So A11 multiply x1 give you this term, A12 multiply x2 give you this, A13 multiply x3 give you third term, equal to B1. And from here, you can rearrange the equation and let x1 to be on your left hand side and x2 and x3 terms on your right hand side. With that, you should be able to obtain this answer, and substitute the x2, x3 from the previous answer inside here. Then you should be able to obtain the answer for x1. Let's try to solve this problem by using the Gauss elimination. So this is our example 1. So during the calculation, we need to carry 6 significant figures. For example, in this case, you have 6 significant figures. So this is 6 significant figures as well. To make the writing clear and easy to follow, we convert it to the matrix format, and in the first forward elimination, we need to change these two elements into 0. To achieve this, we need two factors, factor F21 and factor F31. Since these two elements need to eliminate to be 0, So we need the first equation to be our pivot equation, and the pivot element is equal to 3. So we can find the factor for the F21 to be 0.1 divided by 3, and then 0.3 divided by 3 here to be our factor F31. So we can take the second equation, which is this component, and minus with the pivot equation 1, which is this component, and multiply with the factor F21. So with that, take the 0.1 minus with 3 and multiply with F21, give you this term. 7 minus with negative 0.1 multiply with F21, give you this term. Negative 0.3 minus with negative 0.2 multiply with F21, give you this term. Lastly, take the negative 19.3 minus with the 7.85 multiply with F21, give you this term. Similarly, we can perform this formula by taking the equation 3 here minus with the pivot equation 1 and multiply with F31. Using similar procedure, you should be able to obtain this answer. And then when you look at this component, when you substitute F21 inside, 3 can be cancelled. 0.1 minus with 0.1 gives you 0 for this term. And then you substitute F31 inside this, you should be able to obtain 0 as well. With that, you success to perform the forward elimination 1. Next, we continue with the second forward elimination to eliminate this term into 0. Let the second equation here to be the pivot equation, and then let the 7.00333 to be the pivot element. So you can obtain the F32 by taking the negative 0.19 divided by pivot element here. Then we take the third equation and minus with the second equation here and multiply with F32. So you have 0 minus with 0 multiply F32, obtain 0 here. So the second term here you have negative 0.19 multiply with 7.00333 multiply with F32, which is this term. And if you continue, you should be able to obtain these two remaining terms. Once you substitute F32 inside this term, you should be able to obtain this equation. And then you see you have upper triangular where you have 0 at the lower part here. Then you can perform the backward substitution to find the x3 first, which can be obtained by 70.0843 divided by 10 here. So the answer for x3 is 7. So you can substitute 7 inside x3 here. So refer to the second equation, you have 0 multiply x1, which is 0. 7.00333 multiply x2 minus with 0.29333 multiply with 7 equal to this. With that, you should be able to obtain x2 to be this term, and after you calculate, you get negative 2.5. By using the same procedure, you can find the x1 from the first equation here. So 3 multiply x1, this term multiply x2, negative 0.1 multiply with x3 here, where your x2 is equal to negative 2.5, x3 is equal to 7. So this equation is equal to 7.8. With that, you can compute the x1 to be 3.